Alright, so when we look at the volume of a pyramid, it's important, I left the letter A, that didn't look right. It's important to spell pyramid right, but also talk about what kind of pyramid we mean, because there are different kinds of pyramids in the world. We're only going to be doing the volume of one of those, and this is in particular called a rectangular pyramid. And the reason why it's called a rectangular pyramid is because the base of it is rectangular. You could have a pyramid where the base of it is triangular, and that's called a triangular pyramid. So we are focusing on rectangular pyramids for finding these volumes. Also, some people struggle with seeing the shape here, so I want to emphasize that these dotted lines you wouldn't actually see. That's kind of like in the background. It's just drawn to emphasize the shape of it. This is a lot easier to see what it is when you're actually holding the pyramid in your hands because it's a three-dimensional shape, and it would be nice if you had the actual three-dimensional shape. So when we're talking about the volume of a rectangular pyramid, it's hard to see why the formula is what the formula is. So I'm going to start out just by giving you the formula, and then I'll talk a little bit more about that. This is how the formula is usually expressed. I don't think it's very clear because it's using the letter B differently than how we've used it so far. So I'm going to write this out in words just to make sure we're all on the same page on what this is actually saying. Alright, so the volume is 1/3 the area of the base times the height. So again, our base is this rectangle down here. And the rectangle itself has, in order to find the area of a rectangle, we talk about that as length times width. So there would be a length here and a width here. Sometimes if we might think of that as base and height like we did when we did like parallelograms and stuff, but you're going to find that area of the base. So when we talk about the area of the base, that is a calculation in inside itself. So you won't be given B. You have to calculate B because it's the area of the base. You calculate it by determining the length and width and multiplying the length and width. And then for the height, that is a little that isn't immediately obvious either, and so again it's hard to show, but you're going to take the height that's going to go straight up from your base and form a perpendicular with the point. Sometimes this is drawn from the middle and it just has to be perpendicular to the base. It's really hard. This is really hard to see what's going on. So I'm going to put another image on here that embeds a pyramid inside of a rectangular solid. Alright, so here I just put a pyramid inside of a rectangular solid, and the length and width that I would talk about would be the length and width of that rectangular solid. The height that I'm trying to describe is the height from the base to the tip, but it's perpendicular. It's a perpendicular height. So if you just set the pyramid on the table and measured from the table to the point going straight up, then that would be your height. It is not the distance along the slanted height of the pyramid. So hopefully that helps you see what the height of the pyramid is. It's not actually touching the pyramid. It's going to go straight up from the bottom of the pyramid to the tip of the pyramid. So, you know, if I did that inside the pyramid, which is how it's drawn sometimes, you go from the center of the base up to the point and then do a little perpendicular like that. It's the same height regardless because you're always going from the tabletop where the pyramid's sitting to the point of the pyramid straight up, not alongside the pyramid. So now that we have those, I want to talk a little bit about the formula and why it is what it is. I can't prove it to you because that takes calculus, but I just want to talk a little bit around why it is what it is. So first of all, if you have your rectangular prism, you have length times width times height, and that's what we have up here. So this part here the length times width times height, is just finding the volume of the rectangular prism that would encompass the pyramid. And then the pyramid is obviously, the pyramid's volume is less than that. In particular, it's less than that by a third. That's the part that I can't really show you. If I could show you in person, you take and you can just fill up a pyramid and dump it into the rectangular solid, it fills it up by a third. But to show you specifically why it's a third takes some calculus to measure, so to demonstrate. So that's one of the things that you're just going to have to remember. It's not the whole rectangular solid, and it's less by a third. Well, it's less by 2/3 if I say that correctly, but it's the third of a volume of a rectangular solid. Alright, so now that we've looked at what the formula is a little bit, I put a pyramid up here that has some measurements on it so we can determine its volume. So the volume there is going to be 1/3 the area of the base, and I just like to write this out in words, because if you just put a B, I think that it can be confusing with what we use B for in other places. So the area of the base times the height, and that's okay to use an H because we pretty much always use H for height here. So the area of the base, so we're going to have 1/3, the area of the base would be the 10 inches times the 8 inches. And then the height would be 6 inches. So you get all that written out, and then you calculate it out. And what you're going to get is that it's 160 for the 1/3 times 10 times 8 times 6, and then inches cubed, because inch times inch times inch is inch cubed. And so that's how you use the formula for the volume of a pyramid to find its actual volume in measurements. So it would take 160 cubic inches to fill this pyramid up, though we'd have to cut some of them into pieces to make it work. Alright, go ahead and give some of these a try and see how you fare.